All right. So today, I'm going to be answering a question that a lot of students are asking, and a lot of students probably have, but they probably aren't asking the question. And that is, why are we factoring quadratic equations? So today, that is going to be our topic. I'm briefly going to talk about why we are, and then give you a couple examples as well as a visual to show you exactly why we are factoring these quadratic equations. And so you're probably wondering, why in the world are we factoring, and why does the equation have to be equal to zero? Is this just busy work to pass time and confuse us? If this is your thought, you probably aren't alone. As teachers, we were students and we had this same exact thought. So I want to answer this question for you. So today we're going to briefly talk about why we're factoring and why we want to solve these quadratic equations when they are equal to zero, not equal to 5 or 10, because 10 has a zero. We're looking for when these equations are equal to zero. And let's talk about an example for it. So let's do an example. It says factor and solve. So we have the equation x squared plus 2x minus 3 is equal to 5. Again, we need to have the equation equal to 0. So in order to do that, I first need to subtract 5 on both sides. So we get x squared plus 2x now minus 8 is equal to 0. And again, that is crucial. Being equal to 0 is crucial. So now we can factor. We have x squared plus 2x minus 8. That means we need factors of negative 8 that will add up to positive 2. Well, we can do this. We get x plus 4 and x minus 2. And again, still equal to 0. So now when we want to solve this, we're going to use the zero product property. And again, the zero product property says that if I have two factors and they, when multiplied, equal 0, well, we need to find values. That way, one of those factors is 0. So we want to see when x plus 4 would be equal to 0, because if I highlighted everything in green, if that's 0, well, 0 times x minus 2 is still 0. Likewise, we want to see when x minus 2 is equal to 0, because if we have x minus 2 being 0, then x plus 4 times 0 is still 0. That's the zero product property. So let's break it apart. We're going to have x plus 4 when that's equal to 0, and then when x minus 2 is equal to 0. To solve for the left-hand side of x plus 4, we need to subtract 4 both sides. And over on the right-hand side, we're going to add 2. Ooh, I got to go back. There we go. So we get that x is equal to negative 4 and positive 2. Right, so this would be the answer for the question. It says factor and solve. So we solve by factoring. We found that x is going to be equal to negative 4 and x is going to be equal to 2. But let's see what happens if we did this and we didn't have it equal to 0, right? So again, the reason number one is if we factor this equation the way it is, something fishy is going to happen. So if we start out and we look at x squared plus 2x minus 3, well, we can factor that. We want to find factors of negative 3 that add up to positive 2. So we get x plus 3, x minus 1. And that's equal to 5. So now what this is telling us is we need to find values of x that when we plug in simultaneously right here and right here, whoop, bad arrow, this has to be the same number. So when we do that, we are trying to find values of x that when we plug it in, simplify down, and then multiply to 5. Now, if we go back to what we did before, we found that x was equal, what was it, to 2 and -4. So if we plug these in, we can see it works. Because if I have 2, then I get 5 in the first one, and 1. So 5 times 1 is 5. And if we plug in -4, then we get -1 in the left set, and -5 in the right set, and then we still get 5. But we were only able to do this because we know the answer. If we didn't know the answer, then this would be a long and tedious process for us to say, okay, does 1 work? No. Does 2 work? No. Does 3 work? No. Does 4 work? No. So we need to keep, well, 2 does work there. So 1, does that work? No. 2, yeah, it does. 3, no. 4, no. So we would have to go through every single number to find the factors of 5. And that isn't fun. So factoring, when it's set equal to 0, is going to allow us to use a zero product property that's going to help us find those values of x. Because if we have it equal to a number that's not 0, then we need to go back to guess and check. And if we have some really large numbers, it is going to be a pain in the dupa. So trust us on that. That's why we want to have it equal to 0. So that's reason number 1. Let's jog back your memory real quick and let's think back to linear equations. When we worked with equations similar to y equals 2x plus 3, we can calculate the x and the y intercepts by setting the variable we are not calculating equal to 0. So if I want to find the y-intercept of y equals 2x plus 3, then that means that x is going to be 0. So I get y equals to 2 times 0 plus 3. So we get y is equal to 3. So the y-intercept is going to have a value of 3. And we can see this is in slope-intercept form, so we can automatically deduce that, oh, well, this is 3 because of slope-intercept, right? But we find the x-intercept over on the right-hand side. Again, we need to set that y is going to be equal to 0. So 0 is going to be equal to 2x plus 3. In order to solve this, I got to subtract 3 on both sides. So I get -3 is equal to 2x. Whoa, that's about x. And now we divide both sides by 2. So we get that x is equal to -3/2, right? So that means our line is going to cross over the x-axis at -3/2. Well, if we look when quadratics are equal to 0, we can think of it as being a function that is quadratic, where if we set f of x, or we also call it y, equal to 0, then we can find the x-intercepts. So that's our second reason. By factoring, we're finding those x-intercepts. We're finding when our equation, when our what we call a parabola or a parabola, if you're trying to be silly, when that crosses over the x-axis and at what values. So if we go back to our example that we started out with, x squared plus 2x minus 8. Again, because it had to be equal to 0, so we had to subtract that 5 coming over. If we want to graph strictly x squared plus 2x minus 8, we can bring back what we already found, and that were the zeros. We knew that the zeros were 2 and -4. Right? We had x minus 2 times x plus 4 is equal to 0. We solved for it, and we got x is 2 and -4. Well, when we graph it, this is what it looks like. Come on. So it looks like this, where if we look on the x-axis, if we look on this x-axis, well, the x-intercepts have values of being 2 and -4. So that's why we're factoring, because soon we're going to be graphing these parabolas. And if we can find the x-intercepts, it's going to be very helpful. We also have two smaller topics that we are going to be talking about later But again, these are your x-intercepts. You know what? Let me get rid of this highlighted form because it is confusing. So we also can find the y-intercept, and then we have in red what we call the vertex. But we're going to be talking about that later. But I wanted to answer the question that saying, why do we factor? Well, this is why we factor, because when we start to graph, we're going to want to know the x-intercepts. And by factoring, we can find those x-intercepts that's going to help us calculate the vertex, the y-intercept, and show the way the graph is trending. I hope this video helps. If not, let me know. But I hope that this answered the question as to why we're factoring and taking so much time to do it. It is not just busy work. There is a meaning to it, and this is the meaning. Thank you so much for tuning in. Have a great day.